So, you've always wanted to explore the past or peek into the future, right? Maybe travel back to witness dinosaurs or fast forward to a world where flying cars are the norm. Well, I'm here to break down the science behind time travel using actual theories from physics. Is it possible? And if so, what does it really take? Let's dive into the world of wormholes, relativity, and paradoxes to figure out whether we're living in a science fiction novel or if there's real potential to jump through time. Lesson 1. Einstein's Relativity: How Speed and Gravity Affect Time. First, we need to understand a fundamental principle of physics. Time isn't what you think it is. I know, it feels like this constant thing, ticking along no matter what, but it turns out time is kind of flexible. This is where Einstein comes in. His theory of relativity changed how we think about time. In simple terms, the faster you move, the slower time passes for you. This is called time dilation, and it's been tested and proven. Here's an easy way to picture it. Say you're an astronaut and you hop into a spaceship that's moving close to the speed of light. You spend a few hours zooming around the galaxy, but when you return to Earth, surprise! Years have passed on the planet. Time moves slower for you because of your incredible speed. So, technically, yes, you've time traveled, but only into the future. This isn't a loophole, it's a fact of physics. NASA astronauts who spend months on the International Space Station actually age a tiny bit slower than the rest of us. Cool, right? But there's a catch. Traveling forward in time is possible, but once you're there, you can't just turn around and come back. It's a one-way trip, so while you're hanging out in the future, your past self and everything you knew back home are long gone. Lesson 2. Wormholes: The Hypothetical Shortcuts. Now, if going forward in time is relatively straightforward, what about the holy grail of time travel? Going back in time. Enter the wormhole theory. Imagine space and time are like a massive piece of fabric, and instead of moving through the fabric like we normally do, what if you could fold it? This fold would create a shortcut between 2 points in space-time. Boom, you're here at point A, and suddenly you can jump to point B, possibly even in the past. Wormholes are theoretical tunnels through space-time, and yes, they exist in Einstein's equations. But hold up, we've never actually found one, and even if we did, it would collapse on itself faster than you can say paradox. To keep it open long enough to travel through, scientists believe you'd need exotic matter, something that doesn't exist yet. Plus, traveling through a wormhole is risky business. The gravitational forces could tear you apart before you even reach your destination. And let's not forget, opening a wormhole doesn't just take energy, it takes an absurd, practically unimaginable amount of energy. So, while wormholes make for cool science fiction, we're not even close to pulling it off in real life. Lesson 3. The Grandfather Paradox: The Time Travel Problem. So, let's say we did manage to travel back in time. What happens then? Welcome to the wild world of time travel paradoxes. One of the most famous ones is the grandfather paradox. Let's say you go back in time and accidentally prevent your grandfather from meeting your grandmother. Now, your parents are never born, which means you're never born.
It was at this moment that he knew. He f***ed up.
But wait, if you're never born, how did you go back in time in the first place? This paradox is the stuff of nightmares for physicists. It breaks the very fabric of causality, cause and effect, and basically suggests that time travel to the past can create contradictions. If you can change the past, then everything we know about the universe would collapse into chaos. Some scientists have tried to solve this with the idea of self-consistency. This means no matter what you do, events will play out in a way that keeps the timeline intact. You might think you're changing things, but it turns out you're actually part of the timeline all along. So even if you go back to stop your grandfather from meeting your grandmother, something else will happen to ensure you still get born. Lesson 4. Parallel Universes: Another Way to Cheat Time. Now, if all that talk about paradoxes is making your head spin, let me hit you with another theory: parallel universes. You might have heard about this one if you're a fan of Marvel or any sci-fi that loves multiverse talk. The idea is that every time you make a decision, an alternate universe branches off where the opposite decision was made. In the context of time travel, this means that if you went back and prevented your grandfather from meeting your grandmother, you wouldn't erase your own existence. Instead, you just create a new timeline where that happened, while your original timeline stays intact. It's a clever workaround for the whole changing the past issue. Conclusion: is time travel fact or fiction? So, is time travel possible? The answer is both yes and no. Traveling to the future is totally within the realm of possibility, but it's a one-way street for now. Traveling to the past remains a tantalizing idea, but it's riddled with challenges like paradoxes, enormous energy requirements, and a lack of exotic matter. For now, time travel remains largely the domain of science fiction, but with every new discovery, we're getting closer to understanding the nature of time itself. Who knows? Maybe one day, you'll be able to hop into a machine and visit both the past and future. Until then, we can dream.